Now let's take an example for the calculation of rate of a reaction, average rate of reaction. For this we have a question. I have taken this question from the textbook. From the concentrations of butyl chloride CH4H9Cl at different times given below, calculate the average rate of the reaction. Um, this is the chemical reaction which is involved in this process, and during different intervals of time we have to calculate average rate of reaction. So what equation could be formed for this reaction? Let's solve it and see. So we have this reactant butyl chloride. It can be represented like this: rate of reaction or average rate of reaction is equal to change in concentration of butyl C4H9Cl butyl chloride divided by time taken, or change in time. Now we know, because it is a reactant, therefore its concentration will decrease, so we have put negative in front of it. Now let's find average rate of reaction between these two values, between 50 seconds and 100 seconds. It means the reaction has completed 100 seconds, and now we want the average rate of reaction of this reaction, for this reaction between 50 to 100 seconds. For this, let's put the values into proper way. Now change in concentration, this is final and this is initial for this reaction, for a rate between 50 and 100. So we'll put these values like 0.0820, and the initial value is 0.0905. So bracket close, and now it's time to take the value of time. Final time is 100 seconds, and then it started from 50 seconds. This is the initial value we have with us. So this is how these values will be put together. Now after subtracting the value, these two values and these two, we get, let's keep negatives with us, and this value will be minus 0.0085, and the value is 50, 100 minus 50. This is what we are going to have. Now we have to divide 0.0085 by 50, but before that we have two negative values. It will make together a positive value, so let's make it write it once again: 0.0085 by 50. Okay, let's make some space for it. So the value is going to become 0.00017, and the unit is mole per liter per second. So this is what we are going to note it down, but it can be turned into scientific notation. For this, let's shift this decimal over here. It will now become 1.7 into 10 raised to the power minus 4 mole per liter per second. This is how these values are calculated. Now let's practice one more. So next we are going to take these two values, we are going to find average rate of reaction for this particular reaction when it has completed 150 seconds. We are going to find it between 100 to 150 seconds. So this is final time, this is initial time, this is final concentration, and this is initial concentration for the same reaction. So let's note it down once again. I'm again writing the formula. Average rate of equation, uh, rate will be negative because it is a reactant, and butyl chloride C4H9Cl. Now this is change in concentration of butyl chloride and divided by change in time. For this reaction, this particular reaction, the values will be again 0.0741. Okay, this is the value 0.0741. Okay, and this is going to be subtracted next value to be taken is 0.0820. We have these values, so let's change it. Let's put bracket, and then we have time. For this we have 150 minus 100 seconds. So let's come to the another page for calculation. Now the value comes out to be minus, and it is 0.0079 after subtracting, and then we are dividing the value with 50, and this whole value is negative, so this is going to become positive 0.0079 by 50, and when calculated this comes out to be 0. We have 3 zeros and 158, and the unit you all know, mole per liter per second. So this is going to be rewritten again in the scientific notation, in which we have to shift this decimal over here, so it will become 1.58 into 10 raised to the power. How many places we are shifting? 1 2 3 4, so it will become minus 4, and again mole per liter per second. This is the value we are going to obtain. This is the average rate of reaction when it has proceeded from 100 to 150 seconds. Now let's consider one more numerical from the textbook. Now this question says, in a reaction 2A gives products, the concentration of A decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. Calculate the rate during this interval. So in this question we have 10 minutes for time. Before this we were using other unit per second or seconds for time. Now we have to use minutes. So for this particular reaction, if we are going to write average rate equation, how we are going to write it? Let's see. Rate of reaction will be equal to minus delta concentration of A, and then we have divided by time. Now we have 2. What is the difference it is going to make in this equation? This 2 will be placed here as 1 by 2. 2 moles of A giving products, so this is kept here, 1 by 2. This is the equation we are going to solve. Now let's put the values. Decreases from 0.5 mole per liter to this much. This is initial value and this is final value of concentration, change in concentration. So we are putting negative 1 by 2, and then we are putting these values. How much? This will be placed first because this is final, and subtracting it by initial concentration 0.5, and then it took 10 minutes, so let's write 10. This is the simple way it is to be written as, and then we have these values minus 1 by 2 and subtract 0.4 and 0.5, which comes out to be minus 0.1. We have these values and we can rewrite this as these negative will cancel, minus will cancel out, and 2 can be multiplied to this 10. Now it can be rewritten as 0.1 divided by 20. Is it clear? Negatives are cancelled, they become plus, and 2 is multiplied to 10. On calculating further, this is going to become 0.005. Now what will be the unit? We have concentration, mole per liter per minute. This will be the answer for this particular problem.